So this is exactly what you will be able to do with today's tutorial. In this video we're going to work with pose detection using Yolov8, and I'm going to show you the entire process, from how to annotate your custom data for free using a computer vision annotation tool, how to prepare your data and your file system for training this pose detector, how to do the training in your local computer and also from a Google Colab, and how to do a super comprehensive evaluation of the model you trained. This is a much more complex problem. In my previous tutorials I show you how to train an image classifier using Yolov8, an object detector and an image segmentation model, and I will say that today's model, this Keypoint detector, is much more complex than everything we did before. This is going to be an amazing tutorial. My name is Felipe, welcome to my channel, and now let's get started! And now let me show you the data we are going to use on this tutorial. We're going to use the AWA post dataset, and let me show you exactly how this data looks like. So you can see that these are pictures of many different animals. Currently we are looking at antelopes. These are pictures of many different antelopes, and if I scroll down in this directory you are going to see I also have other animals. For example, here this is a bobcat, which is some sort of feline, some sort of cat. You can see that these are many different pictures of this animal, and if I scroll down a little more, you are going to see I also have buffaloes. So we also have pictures of buffaloes, and if I continue scrolling down you are going to see other pictures of other animals. For example, here I have a chihuahua, and you get the idea, right? We have pictures of many different animals, and all of these animals are quadrupeds because this is a quadruped keypoint detection dataset. Now let me show you the key points we are going to be detecting for each one of these animals, and you can see that these are many different key points. We have 39 key points in total, which is a lot, and we are detecting many different parts. For example, the nose, the eyes, the jaw, the tail, the legs, and also the ears, the horns, or whatever they're called, something like antler, it doesn't matter. We are detecting many different parts in these quadrupeds. So this is exactly the data we are going to be using today. I thought it was like a very cool dataset to use in pose detection, and now let's continue. So I'm going to show you how to do the entire process of training a pose detector using Yolov8 on your custom data. And in my case, the data I am going to use in this tutorial is already annotated, right? So I already have the annotations for this data, but if you are training this pose detector on your custom data, then most likely you will need to annotate the data yourself. So I'm going to show you how you can do that. I'm going to show you how to do the entire annotation process using CBAT, which is a very popular and a very awesome annotation tool for computer vision, and let me show you how to do it. So I'm going to cbat.ai, this is CBAT website, and I'm going to click here where it says start using CBAT. I'm going to show you how to create a project, how to create a task, and how to do all the annotation. Now I'm going to projects, and I'm going to click the plus button. I'm going to click here and create a new project, and this is going to be keypoint detection. This is going to be quadruped keypoint detection, which is exactly what we are going to be doing. Then add label, and I'm going to add quadruped, continue, and that's pretty much all. Submit and open. This is where you are going to add absolutely all the labels you have in your custom data. In my case, I only have one label, which is quadruped. Now let's continue. Now I'm going to create a task, create new task. The name of this task will be something like quadruped keypoint detection task 001. And I am going to add an image. I'm going to show you how to annotate this data with only one image. So I'm only going to select the first one, and then I'm going to click here in submit and continue. We have to wait a couple of minutes until the data is uploaded into the server, and once everything is completed we need to go to tasks. This is our project and this is the task we have just created, and I'm going to click in open. So this is pretty much all. Now I'm going to click here. This is going to open the task, and now we need to start our annotation process. So you need to click here where it says draw new points, and you need to select the number of points you are going to annotate. In my case, I'm going to annotate 39 points, but you need to select as many points as you are going to annotate. So now I'm going to click here in shape, and we need to start our annotation process. And something that's very, very, very important is that once you are annotating your data, you need to follow a given order, right? Once you are annotating all of your key points, you need to follow a given order with your key points. If I show you this image again, you can see that we have many different key points. We have the location of all the key points, but we don't really have any information regarding the order of these key points, right? This is very, very important because you cannot follow any random order. You need to follow a given order. You need to follow always the same order when you are annotating your data. So this is, for example, the order I am going to follow in this tutorial. You can see that the first key point I'm going to annotate is nose, then upper jaw, then lower jaw, mouth and right, and so on, right? You need to specify a given order for your data. Now I'm going to start this annotation process. So the first point is nose, which I'm going to set over here. Then the next one is upper jaw, which is going to be something like this, lower jaw, here, mouth and right, and this is the right from the perspective of this animal, right? So this is going to be here. Now mouth and left, and I don't really see the mouth and left, but I'm going to say it's around here. And I'm going to share a few comments later on this tutorial regarding the visibility of our key points, right? But for now, let's just continue. Now the next one is right eye, then right ear base, which is here, and then right ear end, which is over here. And I'm just going to continue with all of this list, and I'm going to resume this video when I'm completed. And these are the last two, body middle right, which is around here, and body middle left, which is around here. I don't see it, but it's around here. And you can see that this is all. These are my 39 key points. And now let me show you how you can export this data. But before, please remember to click save, otherwise it's always a good practice to click save. And not only you need the key points, but you also need to draw a bounding box around your object. This is very, very, very important, and I'm going to tell you why in a few minutes. But for now, remember that not only you need to annotate all of your key points, but you also need to draw a bounding box enclosing your object. So this is how I did it, and I'm going to click save again. This is the only image I'm going to annotate, but please remember to follow exactly the same process for all of your images. And now I'm going to tasks, and I'm going to show you how to export this data. You need to click here and export task dataset. Now you need to click here, and you can see that there are many different options in which you can export your data, and one of these options is Coco Keypoints 1.0. And this is very important because this is the exact format we need for our data. But I have tried to export the data into this format and it's not working. For some reason, it's not working. So I'm going to show you how to do it in CBAT for images 1.1. So click here, then OK. And then you just have to wait until everything is downloaded. Once everything is fully exported, you are going to see a file, a zip file, and within this file there will be another file called annotations.xml. Now let me open this file so I can show you how it looks like. You are going to see something like this, and at the bottom of this file you are going to see all of your annotations and all the images you have annotated and its annotations, right? So this is exactly the data you are going to generate using CBAT. Now, let me show you something else. I have created a Python project for today's tutorial, and let me show you a script I created in this Python project. And this script will be super useful because now that you have your annotations, now that you have your data, you need to convert your annotations into the exact format you need in order to use this post detector using Yolov8. So let me show you. Basically, you need to specify two variables. One of them is the location of your annotations.xml file, and you also need to specify the location of the directory where you want all your data to be saved, right? This script is going to parse through this XML file, is going to parse through this file, and it's going to extract all of your annotations, and it's going to save all of your annotations into the exact format you need in order to use Yolov8. So remember to specify these two paths, these two variables. One of them is the location of your XML file, and then where you want all of your newly created annotations to be saved, right? Where you want this output directory. So once you have set these two variables, the only thing you need to do is to run this script and everything will run super smoothly. And remember, this script will be available in the GitHub repository of today's tutorial, so you can just go ahead and use it in order to convert all of your data into the format you need to use Yolov8. And now let's continue. Now I'm going to show you how you need to format, how you need to structure all of your data and your file system so it complies with Yolov8. So you can see that this is a directory which is called data, and this is the root directory where my data is located. You need a directory which will be the root directory where your data will be saved, where your data will be located. Within this root directory, you can see I have two folders. One of them is called images and the other one is called labels. It's very important that you name these two folders exactly like this. One of them should be called the images and the other one should be called labels. That's very important. Now, if I open one of these folders, you can see that I have two other folders. One of them is called train and the other one is called val. And it's very important that you name these directories exactly like this. One of them should be called train and the other one should be called val. So within train is where we will have all of our training data, all of your training images, right? You can see that these are all of our images, which are all the images we are going to use as training data. And within val, it's exactly the same. This is all the images we are going to use as a validation data, as our validation set, right? So within images, we have two directories. One of them is called train, the other one is called val, and within each one of these directories is where we have all of our data, all the data we are going to use in order to train this model, all the images we are going to use in order to train this model. But we also have additional data, which are the labels. Now let me show you how this other folder looks like. You can see that within labels, we also have two directories, which are also called train and val. And it's very important that you name these two directories exactly like this. One of them should be called train and the other one should be called val. And if I open the train directory, you can see that we have many txt files. And these are basically all of our labels for the training data, for all of our training images. If I go back to images train, you can see that for absolutely every single one of these images, we have an annotations file, right? For absolutely every single one of these images, we are going to have a txt file in this folder. And now let me show you for the other directory, for val, it's exactly the same, but for the validation data, for the validation images, right? So if I go back again, you can see that we have in the root directory, then images, labels. Within images, we have two directories, train and val, and within each one of these directories is where we have all of our images. And if we go to labels, we have also two directories, train and val, and within each one of these directories is where we have all of our labels. So this is exactly how you need to structure your file system. And now let me show you one of these annotations files, one of these labels files from the inside. Let me show you how they look like. So this is a random annotations file, this is a random txt file, and this is exactly how you need to put all the data inside these files. The annotations are specified in the Coco Keypoint format, which is a very popular format for post detection. Now let me show you something. I'm going to do something which I'm obviously not going to save the changes, but it's going to be much better in order to show you how this annotations format works, right? How it looks like. So basically you can see that the first number is a 0 and this is our class ID. In my case, I only have one class, which is quadruped, so in my case, this number will always be 0. But if you are making this project and you have many different classes, please remember that this number should be the class ID. So if you have different classes, you will have different numbers here. Now, the next four numbers are the bounding box of your object, right? Remember in CPAT, when we were annotating this data, I show you that not only we need to annotate the key points, but we also need to annotate the bounding box, right? And we annotated the bounding box. So these four elements, the four elements that come after the class ID are the bounding box, right? And this bounding box is specified in the YOLO format, which is the X and Y position of the center of the bounding box, and then the width and then the height of your bounding box. This is very important. So these two numbers are the XY position of the center of your bounding box, and then the width and the height. And then all of the other numbers, let me show you, you can see that we have these two numbers which are a float, and then we have the number 2. And then we have exactly the same, two numbers and another 2. Then two numbers and another 2. Then we have 3 zeros, right? This looks like very, very strange. So now let's go back to my browser because I want to show you this website, which is cocodataset.org, and this is where we are going to see exactly how this format works. So if I go back to Keypoint detection, you can see that this is our explanation about how this format works. And if I read something which is here, you can see that absolutely every single key point will be specified as X and Y and a visibility flag B. So this means that for absolutely every single key point, we are going to have 3 values. We are going to have the X and Y position of that given key point, and we are also going to have another value which is B, which is the visibility, right? Remember, we were going to talk about visibility later on this tutorial. This is later on this tutorial. So you can see that B has 3 possible values. B could be 0, and this means that the key point is not labeled, and in this case X and Y is going to be 0 too. Or B could be 1, and this means the key point is labeled but is not visible. Or B could be 2, and this means the key point is labeled and it's also visible. And if we go back to the to this file, to the annotations, you can see that if we start over here, we have 2 numbers and then we have a 2, which means this key point is annotated, is labeled, and is also visible. Now if we continue, you can see that we have 2 numbers and then we have another 2, which means this other key point is also visible. Now if we continue, you can see exactly the same, 2 numbers and then a 2. And then if we continue, you can see that this we have 3 zeros. And we are in this situation, right? B equals 0, so we also have X and Y equals 0. And this means the key point is not labeled for this image, right? So long story short, after the bounding box, all the other numbers will be the key points. And you will have 2 values for the X and Y position, and then the third value will be the visibility of that given key point. Now, this is one of the possible formats in which you could format your data, and this is going to work just fine, but Yolov8 also supports a key point annotation with only 2 values, which means that if you don't have the visibility information for all of your key points, then it doesn't matter, because Yolov8 also supports you input your key points with only the X and Y coordinates. So long story short, we have the first number, which is the class ID, then we have 4 numbers which are the bounding box, and then all of the other numbers are the key points. And you can specify your key points with 3 coordinates for every key point, which means we have the X and Y and also the visibility for that key point, or you can specify all of your key points with only 2 coordinates, which means it's the X and the Y coordinate of that given key point. So this is the way you need to label your data, this is the way you need to structure all of your annotations, and please remember to do it this way, otherwise it's not going to work. So now I'm just going to press Ctrl Z, because obviously I'm not going to save all of those changes, and that's pretty much all about how to format your data, how to format your file system, and how to put your data into the exact format you need in order to train this pose detector using Yolov8. And now let's go back to PyCharm. Let's go back to the PyCharm project I created for today's tutorial. And the first thing you need to do if you want to train this pose detector using Yolov8 is to install the project's requirements, which is basically Ultralytics. So please remember to install this package before starting with this training, because otherwise you will not be able to train a pose detector using Yolov8. So once you have installed Ultralytics, let's go back here to this file I created, which is train.py. I'm going to show you exactly what you need to code in this file in order to do your training. And in order to do so, let's go back here, which is Ultralytics website, and let's go to the pose page, and let's scroll down until this section over here. And the only thing I'm going to do is I'm going to copy and paste this line, and then I'm going to copy and paste this other line, right? So this is basically all we needed to do in order to train this model, and obviously I need to import from Ultralytics, import YOLO, and that's pretty much all. So this sentence over here, we can just leave it as it is, we can just leave it in this default value, but this one I am going to make a couple of changes. I'm going to change the number of epochs, I'm going to train for only one epoch for now, and I'm also going to change the location of the configuration file. I'm going to use this file, which is config.yaml. And now I'm going to show you how this config.yaml looks like. So you can see that this is the configuration file I am going to use in this tutorial. We have three sections, one of them for data, then key points, and then classes. And let's go to the data section first. This is where you're going to specify all the locations to your data, to your images and your labels. So basically, you need to specify the root directory, the directory containing your data, which in my case is this one. Remember, the root directory, this is the directory which contains the images and the labels folders. And then you need to specify what's the location of the training images and the validation images. If you have made everything as I show you in this tutorial, as I showed you a few minutes ago, then you can just leave these two lines in these values, right? You can just leave everything as it is and everything will work just fine. The only thing you need to edit is the location of your root directory. Now let's go to this section over here, which is the key points. And we have two keywords, which are keypoint shape and flip index. And these two keywords are completely and absolutely new for us. This is something we haven't seen before in any of my previous tutorials about Yolov8. And you can see that in the case of keypoint shape, in my case it says 39.3. That's because I have 39 key points and I'm using the X, Y, and B format, right? I'm using 3 values for every single key point. So in my case, that's why I have a 3 over here. So this is how many key points you have in your data, and this is what format are you using. If you're using the X, Y format, in that case you will need to specify a 2, or if you're using the X, Y, and B format, and in that case you will need to set a 3, as I am doing over here. So that's for keypoint shape, and now let me explain what flip index is. And in order to further explain what this keyword means, I made a drawing over here where I'm going to show you exactly what it means. So you can see that this is a random image in my dataset, and actually this is the same image I used in order to show you how the annotation process looks like for this data. And you can see that this is a quadruped with all of its key points drawn on top, right? Now let me show you what happens if I flip this image horizontally, right? This is what I get. You can see that this is exactly the same image, but the only thing I did was to flip it horizontally. If I flip an image horizontally, now everything that used to be one of the sides now is the other side, right? Everything that used to be the right side now is the left side. And the other way around, everything that used to be the left side now it's the right side. That's only what happens when you are flipping an image horizontally. But remember, we had many different key points, and many of these key points were related to one of the sides. For example, we had a key point for the right eye, we also had key points for the right ear, we had key points for the right legs, and the same situation for the left eye, the left ear, and the left legs, right? Many of our key points are related to one of the sides. If we flip the image horizontally, then we should be doing something with all of these key points which are related to one of the sides, right? When we are training a model using Yolov8, when we are training this type of model, one of the steps, one of the stages in this process, in the training process, is to do something which is called data augmentation. And this data augmentation means that we are taking the data and we are doing different transformations with this data. One of the transformations we are doing is related to flipping the image, right? So we are going to be flipping some of our images at random, and every time we are going to be doing an horizontal flip, we are going to have a situation like this. So now let's go back to this list, which is the list of all the different key points we have in this dataset, right? Remember, I already showed you this list when I was annotating this image, and remember, we start with the nose, then the upper draw, then the lower draw, and so on. So you can see that some of these key points are related, for example, in this case, to the right side. This is related to the left side. We have many key points over here which are related to the right side. Then we have many key points which are related to the left side. Then we have other key points which are not related to any of the sides. For example, neck base, neck end, throat, back. These are generic key points and they are not related to any of the sides. And we will need to do something with all the key points which are related to one of the sides. For example, these two, then all of these over here, and so on, right? You get the idea. That's exactly what we need to do, and that's exactly what this flip index keyword does, right? That's exactly the idea, the intuition behind this flip index. So let's go through this list. You can see that the first element is nose, and if we think about a nose, it's right in the middle, and nothing is going to happen when we flip the image, right? The nose will continue being the nose, will remain as the nose. And then the next element is the upper jaw. Exactly the same, nothing will happen with the upper jaw, will remain being the upper jaw after we flip the image horizontally. The same will happen with the lower jaw, but when we get to this element, this is the mouth end right, and we will have an issue here because the mouth end right, when we flip the image horizontally, will be the mouth end left. And the next element, which is mouth end left, when we flip the image horizontally, now it will be the mouth end right. You get the idea? These two values, these two key points will be flipped when we flip our image, right? And now let's take a look at this list we have over here, which is the value for flip index. And you can see that the first element is 0, then 1, then 2, then 4, 3, right? So we are flipping these two values, right? Instead of having a 3-4, which will be like the natural order, we have a 4-3. We are flipping these two values. And these are exactly the indexes of these two key points in the key point order. So, long story short, the only thing we will need to do in order to fix this issue we will have when we are flipping our images horizontally, the only thing we will need to do is going through all of our key points, and all of the key points which are related to the right side, we need to flip them in order to make them the left side, right? We only need to flip the right and the left side. That's the only thing we need to do. And that's what we need to specify here in this list. This is how the flipping will be done. So please be super careful with this list, and this, remember, means how your indexes will be flipped when the image is flipped horizontally. Now let's move to this section, and these are all of your names of all of your objects. In my case, I only have one object, which is quadruped. So in my case, this is very simple, but please remember to specify all the names and all the class IDs for absolutely all of your names. In my case, I only have one class ID, which is 0 and means quadruped. So that's pretty much all for the config.yaml, and now let's go back to train.py and let's continue. So once you have specified this configuration file and you have specified everything we have over here, the only thing you need to do is to execute this script, and that's all. That's how easy it is to train this model. But I'm going to stop this training because otherwise it's going to take a lot of time. If I train this model locally, it's going to take a lot of time. I have been doing some tests already, and yeah, it's going to take forever if I do it locally. But this is exactly the process you should follow if you want to train this model in your local environment. But I mentioned that I'm also going to show you how to train it in a Google Colab. So now let's go to my browser and let's see exactly how we can do this training from a Google Colab. The first thing you will need to do is go into your Google Drive, and you will need to upload absolutely all of your data, obviously, because otherwise you will not be able to train this model from your Google Drive. And also you will need to upload your config.yaml file. And everything will be just exactly the same as the file I show you in my local computer, but you will need to edit this field, which is the path, right? You can see this path over here. You will need to edit this with the path to your data in Google Drive. This is very important, and otherwise nothing is going to work. So please remember, you need to edit this path, and I'm going to show you exactly how to know what's the location of your data in your Google Drive. Now let's go back to this Google Colab. This is the Google Colab I created for this tutorial, for this training, and obviously you will be able to find this notebook in the GitHub repository of today's tutorial. So for now, just follow along. You can see that we have only a few cells, and the only thing I'm going to do is to execute these cells one by one. So I'm going to start with the first one, which is connecting my Google Colab environment with Google Drive. And now the only thing I have to do is to select my account. Then I scroll all the way down and I click allow, and that's basically all we need to do in order to connect our Google Colab with Google Drive. So this way Google Colab will be able to access the data you have in your Google Drive. We have to wait a few seconds, and that's pretty much all. You can see that everything has been mounted here in Content G Drive. And now the next step is to install Ultralytics, right? Because remember, we are going to use Ultralytics, which is the Python package we need to use in order to use Yolov8. And the only thing we need to do is to execute this cell, and everything is now completed. Now, in order to continue with the next two cells, you need to know where your data is located in your Google Drive. The only thing I'm going to do is to execute this cell, and this is going to list absolutely all the files in my local, in my Google Drive and in my root directory, right? You can see that these are many files, and from here the only thing I will need to do is to find where my data is located. In my case, it's located in this folder. If I do ls again, this is the content of this folder, so the only thing I need to do is to locate this directory. And then that's it, right? This is the content of this directory, which is where my data is located. So the only thing I need to do is something like this. And that's the content of my data directory, which contains the two folders, images and labels. Now that you know where your data is located in your Google Drive, now you can just copy and paste this path in your config file, right? Now that you know exactly where your data is located, you can just come here and you can edit this field, and you can just put wherever your data is located. And then you need to specify the location of your config.yaml file. And once you set this location over here, you are all set, and the only thing you need to do is to click enter, right? You need to execute this cell, and that's going to be pretty much all. Now everything is being executed. This is going to take some time. The first thing it's going to do is to download all the weights into this Google Colab environment, and that's pretty much all. It's going to get all the data, and then it's going to do the training. Okay, now the training process has been completed, and you can see that the results have been saved here in runs post train 4. So I'm going to show you how to execute this cell. So we copy the entire content of the runs directory into your Google Drive, right? Remember that the idea of this training process is to download the results, to download the weights, to download the entire results which have been saved here. And the way to do it, or one of the ways to do it, I would say the easiest way to do it, is to copy everything into Google Drive and then just download everything from Google Drive. So this is the simplest way to do it. And please remember to edit this path to the path where you want everything to be copied when you execute this cell. So let me show you. If I go back to my Google Drive, you can see this is a runs directory which was just generated, and within this directory is where we have this train 4, which is the result of the training process we have just executed. So everything seems to be okay, and what we will need to do now is to download this directory into our local computer. Now remember, this was a very dummy training. This is a training we did for only one epoch. Obviously you will need to do like a deeper training if you really want to train your pose detector on your data. One epoch, it's very unlikely to be sufficient. You will need to do like a deeper training. In my case, I have already trained the model with my data, and I did it for 100 epochs, right? I did it before starting this tutorial, so everything is already trained and we can just analyze the results. So now let's move to my local computer so I can show you exactly how to validate the model I trained using Yolov8. And you can see that these are many different plots, many different functions. We are plotting a lot of information, but we're going to focus in the loss function, and specifically we are going to focus in this loss, which is the loss function related to the pose. So we are going to focus on the pose loss related to the training set and the pose loss in the validation set. And if we look at the training set, you can see that the loss is going down. But not only is going down, but I will say that's going to continue going down for even more epochs, right? You can see that the trend is that it's going down and it's going to keep going down for more iterations, for more epochs. We haven't reached a plateau, and I would say that we are very far away of any plateau, right? So this is a very good sign, and it means the training process is going super well, and it means that the model has extra capacity, it has more capacity, so we could continue training this model and it will continue learning more about this data. That's what I take by looking at this pose loss in the training set. And if we look at exactly the same function but in the validation set, we can see that it's going down, so that's a good thing, but I have the impression that it's starting to be something like a plateau, right? It's not very clear because it's happening right in the end of this training process, but you can see that it somehow seems like this is going to be a plateau from now on, right? At the very least, we can see that it's going down there. That's absolutely and 100% clear, and then it's unclear what will happen from now on, or what would have happened if I would have trained this model for more epochs. But it seems we may have reached a plateau, and that's something we need to keep in mind in this validation process. But now let's take a look at exactly how it's performing with some images. So the way I'm going to do it is like this. I am going to open this image, which is one of the batches in the validation set, and these are all labels, right? These are not all predictions, but these are the labels, the annotations. Now I'm going to keep this open, and I'm going to open exactly the same batch, but or predictions, right? This is going to be a very good way to analyze the results, because now we have a lot of images and we need to make more conclusions. We need to take a look at more samples. We need to, this is a much more complex problem. In my previous tutorials, I show you how to train an image classifier using Yolov8, an object detector, and an image segmentation model. And I will say that today's model, this Keypoint detector, is much more complex than everything we did before. So this validation process will be more complex as well. Now, if you look at all of these images, I'm going to focus on only one of them. I'm going to focus on this dog, on this Dalmatian, and I'm going to show you exactly what's going on here. Let's focus on this animal first, and you can see that basically these are all of our key points. These are our ground truth. These are all of our annotations, and these are all of our predictions. And you can see that it looks pretty well. It looks very well. I will say that if we look at all of these key points which are around the face, I will say they are perfect. I would say they are very good. And then if we look at these key points over here, you can see that it's very good as well. If we look at these 3 key points, it's also very good. These 2 key points over here as well, it's very good too. And then if we look at the legs, I can see something is going on here because I don't really see these 2 key points, so we are not detecting the legs. And if I look at the legs entirely, I will say something is going on because I don't really see, I think we have an issue in the legs. And also you can see that this key point, which is at the end of the tail, we are not detecting this key point either. So we have some issues. We have an issue in the tail and we have an issue around the legs, but everything else I will say that is pretty good. I don't know what you think, but I think it's pretty good. So this is one of the examples, and now let me show you another one, which is in another batch. Again, these are the annotations and these are the predictions. So let me show you what happens in this rhinoceros. Let me show you what happens. These are our annotations and these are our predictions. And you can see that we have a similar situation. Around the face, I would say everything is just okay. We have like a very good detection. Then over here, we have very good detection too. These 3 points are very well detected. Then over here, everything is okay. And then we also have an issue around the legs, right? We are not detecting all the key points in the legs properly. The same happens over here with this other leg, and the same happens in the tail, in this key point, which is the end tail. And then everything else seems to be working super properly. We are detecting all the key points, but we have an issue around the legs and around the tail. And now let me show you other examples. For example, this one over here. You can see that in this case we have the animal in a different posture, so it's a little more challenging for our model. And you can see that in this case we are detecting the face very well. Actually, we're not detecting this eye, but other than that, all of the other key points around the face are very well detected. And you can see these 3 key points over here, everything is okay, this one is okay, this one too. And then you can see that we have all key points which are also very well detected, but we have an issue again around the legs, right? And that's pretty much what I noticed by looking at many of these examples, right? In many of these situations, we have many different situations because there are different animals, they are in different postures, they are in different everything. So we are going to notice different situations. But after inspecting a few of these images, I had the impression that the model is performing very well, but we may have an issue around the legs and around the tail. That was my impression by analyzing many of these pictures. So by combining this information, all the information we got by analyzing these images, all the key points, how they were detected and so on, and also combining everything with the loss function, with this plot regarding the loss function in the training set and in the validation set, my conclusions from here will be to make a deeper training, to train this model for even more epochs, and I am curious to see what will happen in that situation, because if I look at the training loss, I really like what I see. I think this model have way more capacity. I think we could train for, I don't know, 50 more epochs, 100 more epochs, and I think we will be in a very good situation. The training loss will continue to go down, and it will continue to go down in this way, right? It seems we are very far away from the plateau, but if I look at the validation loss, I'm not completely and absolutely sure what happened from now on. So what I will do now in order to improve these results, or in order to try to improve these results, will be to continue training for more epochs, and I will see what happens next. I will see what happens with this loss, and then I will see what happens by analyzing these images again, right? That will be my next step by analyzing all this information. So this is a very good example of how to analyze your model, how to analyze your data and your plots and so on in a more complex example as this one, because remember that now we are trying to detect, now we are trying to learn something that's way more complex as we did in our previous tutorials. Now we are not trying to learn like a bounding box or a mask, but we are trying to learn the entire structure of a quadruped. So that's, trust me, it's way more complex than everything we have made so far. So this is a very good example of how to validate a model when the problem is a little more complex. Take a look at the loss function, take a look what's going on, take a look in the training set and in the validation set, and also take a look at some examples, and then just make some conclusions. In my case, what I will do is to train for more epochs. And also, please remember that we are always using the default values of this training, right? We are training this model using all the default values. The only values we are specifying are the image size and the number of epochs, and that's it. And if I show you the entire configuration file we are using, is this one, and you can see that we have many hyperparameters. So another next step, in case a deeper training is not enough, another next step will be to play around with the different hyperparameters and to find another combination of hyperparameters which will be better for our use case. That's very important, because if you are approaching a more complex problem like this one, like the one I am doing right now, I will say that it's not very realistic to expect everything goes super well from the first attempt by using all the default values, right? I will say if the problem you are trying to solve is much more complex, then most likely you will need to play around with the different hyperparameters, and you will need to find a combination of hyperparameters that suits well with your problem, with your project. So that's what I can say about this validation process. And now let me show you something else, which is where the weights are located. Within this folder, you will see another folder which is called weights, and within weights, you are going to see two files which are best.pt and last.pt. These are the models you generated with this training process, and this is something that I have already mentioned in my previous tutorials, but I'm going to say it again. Last.pt is the model you trained at the end of your training process, and best.pt means that this is the best model you trained in the entire training process. So you have these two models and you can just choose the one you like the most, and what I usually do is take in last.pt. I consider that this is a much more robust model, so this is the one I usually consider when I'm making my predictions. And that's pretty much all I can say about this validation, about validating this model. And now it's time to make our predictions. So let's get back to PyCharm and let me show you this file, which is called inference.py. This is the file we are going to use in order to make predictions with the model we just trained. So let me show you how to do it. I'm going to start importing from Ultralytics, import YOLO. Ultralytics, import YOLO. And then I'm going to define my model path. I am going to specify the location of the model we just trained, right? Which is this one. In my case, this is the location of my model. I'm going to select last.pt, and I'm also going to set the path to an image. I'm going to use in order to show you how to make predictions. My image will be located in samples wolf.jpg. Let me show you super quickly the image I'm going to use in order to show you how to make predictions with Yolov8. Let's go to samples, and this is exactly the image I am going to use. You can see that this is the image of a wolf, which is obviously a quadruped, so it's going to be an amazing image in order to show you how to use this model. Now let's get back to PyCharm. And let's do something like this. I'm going to define my model like YOLO model path, and then we're going to say something like results equal to model image path. And I'm going to select the first element because as we are predicting only one image, the first element will be just fine. And then it's just about iterating for result in results. And this will be something like for keypoint in result keypoints dot to list. There. And for now, the only thing I'm going to do is to print keypoint, so we make sure everything is okay. And let's see what happens. Okay, it seems I have an error, and I think I know what's the error. To list goes with without the underscore. So let's see now. Okay, now everything seems to be okay, and what I'm going to do now is I'm going to import cv2 because I am going to read the image and I'm going to plot all the key points on top of this image, right? That's going to be a very good way to show you how to predict all these key points. So cv2 in read image path. This is going to be image. And now I'm going to call cv2.putText. Maybe it's a very good idea to put the text of each one of these key points, to put the key point number on top of each one of these key points. So this is going to be image. Then the key point number will be, let's do it like this, key point index, key point in enumerate. Okay, and then string key point index. Okay, now the location, and remember this is how my key points look like. We have 3 values, and the values we care about in this moment are these 2 because these are the XY position of the key point. So I'm just going to do something like int keypoint 0 and int keypoint 1. Okay, now I have to select the font, which I'm going to set in this one, font Hershey Simplex. Then the font size, which I'm going to set in 1 for now. Then the color. Something is not right. Let me see. I think I'm not closing these brackets. I think that's the reason. 1, 2. Okay, there. Let's see now. Everything's okay. 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 Now the color, which I'm going to set in green. So this is something like this. And then the text width, which I'm going to set in 2. And this is going to be all for now. Now let's see how it looks like, right? I'm going to call cv2 imshow image and my image. Then cv2 weight key 0. Okay, and that's pretty much all. What we are doing here is plotting the image and drawing all the key points on top of this image with the key point number on each key point, right? So it's going to be easier to know exactly what we are detecting in the entire image. And this result, everything looks pretty well, but I'm going to do something so I can improve the visualization. I am going to make the font size equal to 0.5. And I'm going to press play again. Okay, now the visualization is a little better, and you can see that everything looks pretty well, right? We are plotting all the key points on top of our image, and this is exactly how you can make predictions using Yolov8. So the last thing I'm going to show you is to open this file, the class names, and let's take a look at exactly what we are detecting, right? So you can see here 0, we have the nose, then upper jaw, lower jaw, mouth end right, mouth end left, and so on, right? You can see that, for example, 21, we are somewhere around here, which is back middle, it makes sense. Then 37, we are around here, body middle right, and then 36, belly bottom. So everything looks pretty well, and you can see that we are still getting the issues we noticed in the other pictures, which is the legs are not very well detected and the end tail is not very well detected either. But everything else seems pretty well. So this is going to be all for today. If you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of videos I make in this channel. This is going to be all for today, and see you on my next video.